On February 20th, 1943, just north of the Kasserine Pass in Tunisia, events unfolded that no official battle report could fully capture. German tank commanders found themselves facing American Shermans performing maneuvers that contradicted everything the Wehrmacht's doctrine claimed was possible without direct visual signals. Through the thick haze of dust and smoke on the North African battlefield, 5 Shermans, separated by broken ground and with no line of sight to one another, advanced toward German positions with uncanny coordination. There were no flag signals, no flares, no couriers darting between vehicles, yet the tanks moved as if guided by a single will. Each crew covered the blind spots of the others, reacting as though they instinctively knew the exact positions of their fellow tanks. Meanwhile, in their Panzer IVs equipped with Fuji 5's radios, German commanders were fighting not only the enemy but also their own equipment. The static and distortion of their amplitude modulation systems made it difficult to hear even their company leaders. The 10-watt German transmitters, considered cutting-edge technology in the 1930s, rarely carried a signal more than a few hundred meters once the vehicles were in motion. Many German tanks were fitted only with receivers, which meant they could listen for orders but had no way to send back reports or call for assistance. The Americans, however, were relying on technology their opponents had never even imagined. Every Sherman carried a frequency-modulation radio, crystal-controlled, 25 watts of output power, with a clarity that sliced through engine noise and the chaos of battle like paper under a knife. What rolled off the assembly lines in Detroit was not simply another tank, but a machine connected to an invisible network. The most decisive American advantage in the war would not come from thicker armor or larger guns, but from the electromagnetic signals that allowed their tank crews to act as one. This shift had begun nearly 2 years earlier, on July 22, 1941, when the US Army standardized a new set of signal corps radios, the SCR-508, SKR-528, and SKR-538, for all medium tanks. While German units were pushing through the Soviet Union with command vehicles relying on outdated radio links, American engineers at the Galvin Manufacturing Company, later known as Motorola, were perfecting FM technology that would soon make those German systems obsolete. Daniel E. Noble, who first envisioned applying FM to armored vehicles, and principal RF engineer Henryk Magnuski, who solved the daunting challenge of installing delicate electronics in the brutal environment of a tank, spearheaded the project. The equipment they built weighed 181 pounds, but transformed every Sherman into a vital node in what became the first true battlefield communication network. By February 1943, at Kasserine Pass, that invisible edge revealed itself. For the Germans, it seemed inexplicable. For the Americans, it was the beginning of a new kind of warfare. On November 8, 1942, the Allies launched Operation Torch, bringing American armored divisions into the North African theater. Among the Shermans that came ashore near Safi and Fadala were vehicles equipped with the SCR-508 radios, a piece of technology that would soon prove devastatingly effective against German communications. The Afrika Korps, despite being the most seasoned armored force the Wehrmacht had, operated under strict limitations. In a typical German platoon of 5 tanks, only 1 or 2 carried the full FUG-5 transceivers that could both transmit and receive. The remainder were fitted only with Fuji-2 receivers, leaving crews able to hear orders but powerless to respond or pass along vital information such as enemy positions. This structure forced German platoons into a rigid chain of command where orders flowed in one direction and acknowledgement came only through action. When a command tank was destroyed, an easy target thanks to its distinctive multiple antennas, the entire unit could lose coordination instantly. For the Americans, this weakness created an opening. Because every Sherman had a functioning transceiver, any tank could step into a command role if necessary. This difference became painfully clear for the Germans during the Battle of Kasserine Pass, fought between February 14th and 24th, 1943. Although the Germans claimed a tactical victory in the engagement, what caught their attention was the seamless coordination of US forces. In the chaos of that battle, scattered elements of the US 1st Armored Division maintained contact across nearly 50 miles of battlefield. Tank crews who had never trained together managed to coordinate movements, share warnings, and even call in artillery support, all through clear FM transmissions. German signals intelligence units intercepted these communications and reported with unease that American tanks were keeping contact over distances at which their own radios could produce nothing but static. Even more troubling was the realization that transmission was not limited to command tanks. Every Sherman was capable of broadcasting with full clarity. The FUG-5 radios, using outdated amplitude modulation across the 27.0 to 33.3 MHz range, suffered from inherent weaknesses. Their 10-watt transmitters could reach only 2 or 3 kilometers under ideal circumstances, often less than a kilometer once tanks were moving. The roar of engines, electrical interference from motors, and even the firing of spark plugs overwhelmed German equipment with static. By September 1943, American armor had entered Italy. In mountainous terrain that should have neutralized radio advantages, FM sets once again proved invaluable. Where German AM radios fell silent, the SCR 508 cut through the multipath interference of valleys and ridge lines. American tanks coordinated attacks in places where visual signals were impossible, and German crews were effectively deaf. Reports from the US 1st Armored Division describe routine coordination over distances that the Germans believed technically unachievable. For the Wehrmacht, it was a rude awakening. For the Americans, it was confirmation that their edge in communications was turning into a decisive battlefield weapon. June 6, 1944. As the landing craft dropped their ramps on the beaches of Normandy, American Shermans rolled ashore carrying SCR 508 radios that immediately linked them with naval gunfire support. This level of real-time coordination was something German technology simply could not match. Yet the fierce hedgerow fighting in Normandy soon exposed a dangerous gap in the system. Tank crews could talk to each other, but they could not communicate directly with the infantry advancing alongside them. The problem lay in incompatible frequencies. The Sherman's radios operated in the 20.0 to 27.9 MHz range, while infantry units carried the SCR 300, tuned to 40.0 to 48.0 MHz. On paper, the difference was just numbers. In practice, it meant American tanks and infantry were effectively speaking different languages over the airwaves. This disconnect had lethal consequences. In the thick bocage country, German soldiers armed with Panzerfausts could creep dangerously close to US tanks. Infantrymen nearby might see the threat, but with no direct line of communication, they had no way to warn the crews. Several Shermans were destroyed in just this fashion. The American response came quickly and was strikingly simple. Tank crews began mounting EE-8 field telephones inside weatherproof ammunition boxes welded to the outside of their vehicles. These phones were wired directly into the internal communication systems of the tanks. Infantrymen could pick up the handset, call inside, and instantly relay warnings or coordinate maneuvers. By late July, during Operation Cobra, this improvised fix had become standard practice. The results were dramatic. For the first time, infantry and tanks could operate as a fully integrated team. In the narrow lanes and thickets of the Norman countryside, that connection meant survival. Between July 25th and 30th, 1944, the US 2nd Armored Division, under Major General Edward H. Brooks, unleashed the full potential of American radio superiority. Over 200 Shermans maneuvered across the battlefield, each in constant contact with the others. German defenders from the elite Panzer Lehr Division found themselves facing an opponent that seemed to possess an almost supernatural awareness of the fight. American tanks reacted instantly to calls for help. Artillery strikes landed within minutes of requests, and enemy positions were shared seamlessly across units. For the Germans, the contrast was painful. The Panzer Lehr Division, once considered the pinnacle of German armored warfare, had been reduced to near silence. Many of its tanks went into battle without functioning radios at all, forced to rely on visual signals in terrain where visibility was often less than 100 meters. Those that did have radios found them plagued by interference and limited range, making coordinated defense nearly impossible. The irony was bitter. Germany had pioneered the very idea of using radios to control armored formations back in the 1930s. But by 1944, it was the Americans who had turned communication into a decisive weapon. The contrast between American and German communications grew even sharper when measured against the Wehrmacht's own doctrine. Ironically, It had been Germany that first championed the use of radios in tanks. Heinz Guderian, the architect of Blitzkrieg, had insisted since the 1920s that armored units must be able to communicate by radio to achieve rapid breakthroughs. In his 1937 book Achtung Panzer, he emphasized that effective communication was just as essential to armored warfare as armor or firepower. But by 1943, Germany could no longer live up to Guderian's vision. Production shortfalls and resource limitations meant that many tanks rolled off the assembly line without the radios his doctrine required. In that year, the German factories produced roughly 5,700 medium tanks, but fewer than 2,000 full fugue transceiver sets. The gap was glaring. Radios were prioritized for command vehicles or assault guns, leaving most standard tank crews to fight with only partial or no communication. The Soviet Union faced an even bleaker situation. The T-34, celebrated as one of the most important tanks of the war, often entered combat without any radio equipment at all. Soviet doctrine leaned heavily on flag signals, hand gestures, or carefully prearranged plans. This approach proved disastrous in 1941 when German forces, using superior coordination, repeatedly crushed Soviet tank units that could barely communicate once battle began. By 1943, the situation had improved slightly thanks to Lend-Lease. American-made radios, including SCR-508 sets, began to equip some Soviet command tanks. Even so, by the end of the war, only about a quarter of all Soviet tanks carried radios. The comparison underscored the magnitude of the American achievement. While the Soviet Union struggled to get radios into 25% of its armored force, the United States managed to equip virtually every one of its Shermans with advanced FM systems. Much of this success could be traced back to American industry, particularly Motorola's factory in Chicago. Before the war, the company was best known for producing car radios. Converting its assembly lines to military production meant not just retooling machines but solving unprecedented engineering problems. Every SCR-508 radio required thousands of parts manufactured to precise specifications: capacitors, resistors, and crystal oscillators that had to hold frequency stability under the extreme heat, cold, and constant vibration of a tank in battle. The production numbers told the story of industrial might. In 1942, about 3,800 units of the SCR-508 family were built. By 1943, that number had risen to 11,400. In 1944, it soared to 24,000. In total, more than 50,000 sets were produced during the war, enough to ensure that each of the 49,324 Sherman tanks manufactured would be equipped with reliable, crystal-controlled communication equipment. No other nation came close to this level of deployment. The Germans had pioneered the theory of armored communication. The Americans, however, perfected the practice. The advantages of the American radio systems went far beyond simply replacing static with clear speech. What truly set the SCR-508 apart was how seamlessly it integrated into every aspect of tank operations. One of its key strengths was crystal-controlled frequency stability. Crews could preset channels before entering combat and rely on those settings to remain locked, even under battlefield stress. German Fuji 5 sets, which used variable capacitor tuning, constantly drifted off frequency, forcing crews to adjust in the middle of engagements. For Americans, that problem simply didn't exist. The SCR-508 also featured a dual receiver configuration. This allowed commanders to listen simultaneously to their platoon net and to company-level communications. Orders could flow down instantly while situational awareness flowed up, keeping every echelon connected in real time. It was a small technical feature with enormous tactical consequences. Inside the tanks, communication was equally advanced. The BC-606 intercom system connected every crew member. Drivers, gunners, and loaders could alert their commander without needing to shout or resort to hand signals. Throat microphones and noise-cancelling headsets cut through the roar of engines and gunfire. Many German tanks lacked intercom systems entirely, leaving their crews to bang on armor plates or yell over deafening noise to be heard. Power supply was another critical difference. The American radios could operate on either 12 or 24 volts, automatically adapting to the vehicle's electrical system. A dynamotor power supply filtered the current and stabilized output, preventing interference. In contrast, German sets drew power directly from vehicle circuits. Every spark, every ignition cycle, every electrical discharge bled into the radios as disruptive noise. All of these technical advantages reshaped American doctrine. The US Army developed the combat command structure, flexible task forces built from different units for specific missions. This adaptability would have been impossible without reliable radios. Commanders could combine armor, infantry, artillery, and reconnaissance on short notice, confident they could coordinate their movements through a common communications network. For German officers, accustomed to rigid structures dictated by limited communications, this flexibility was baffling. They had built tanks with superior armor and firepower, but those tanks often fought as isolated machines. The Americans, with equipment that seemed merely adequate on paper, fought as coordinated teams. By September 1944, the difference was on full display at the Battle of Arcourt. The US 4th Armored Division clashed with German Panzer brigades that fielded Panthers, tanks superior to Shermans in nearly every technical specification. On paper, the Germans held the advantage in firepower and protection, but the Americans had something more decisive: instant, reliable coordination. Sherman crews radioed enemy positions the moment they spotted them. Tank destroyers were able to target foes they couldn't even see because someone else had transmitted their location. Artillery observers embedded in command tanks called down devastating barrages within minutes. Over 3 weeks of fighting, the 4th Armored destroyed 281 German armored vehicles while losing just 41 Shermans, an astonishing kill ratio of nearly 7-1. It wasn't thicker armor or bigger guns that made the difference, it was communication. Throughout the war, German intelligence consistently misread the true source of American effectiveness. Reports noted the remarkable coordination of US tank units, but usually chalked it up to discipline or extensive training. Even as late as September 1944, one captured German assessment stated, "American tank units demonstrate strong radio discipline and good coordination, apparently the result of rigid procedures and thorough preparation." What the report completely overlooked was that the Americans were fighting with a technological edge the Germans simply did not possess. Because the Wehrmacht never recognized the scale of the communications gap, they never adapted. German forces continued to prioritize attacking command tanks, easily identified by their multiple antennas, assuming that knocking them out would collapse enemy coordination. What they didn't understand was that every single Sherman carried a full transceiver and could assume command duties at any moment. They also planned ambushes, expecting that American tanks, once separated, would lose cohesion. Instead, the radio net held them together regardless of line of sight. By March 1945, this advantage reached its peak. As US forces pushed toward the Rhine, they stumbled upon an opportunity that could have changed the course of the campaign: the Ludendorff Bridge at Remagen, still intact. The discovery by elements of the 9th Armored Division was immediately relayed over the airwaves. Within minutes, word had reached 1st Army headquarters. Within an hour, American divisions across the front were already shifting to exploit the crossing. German units, by contrast, were dependent on telephone lines, most of which had been systematically cut by Allied airstrikes. Orders moved slowly or not at all. Counterattacks came piecemeal, uncoordinated, and easily destroyed by US forces who were reinforcing the bridgehead in real time, thanks to their radio networks. 1 month later, in April 1945, the Ruhr Pocket demonstrated the final culmination of American communication superiority. The 1st and 9th Armies orchestrated a massive double envelopment almost entirely through radio coordination. German formations inside the pocket, more than 300,000 troops, found themselves cut off in part because their communications system had collapsed. Forward air controllers equipped with radios guided American fighter bombers as they methodically destroyed what little remained of German command and control. Field Marshal Walter Model's last desperate transmissions before communications failed entirely revealed the hopelessness of the situation. No contact with adjacent units, no contact with higher headquarters. Fighting continues, but coordination impossible. For American tank crews, the experience was the opposite. Even when isolated on the battlefield, they never truly fought alone. The invisible web of FM signals connected them to their comrades, artillery, and higher command. For German tankers, combat often meant profound isolation, fighting blind with little awareness of the wider battle. In those final months of the war, the radio became as decisive a weapon as any cannon. When the war finally ended, Allied technical teams moved quickly to analyze the equipment their enemies had relied on. Their findings confirmed what countless tank crews had already experienced in battle. German tanks, often praised for their armor and firepower, had catastrophically weak communications. A U.S. Army technical intelligence report bluntly concluded that German tank radios were approximately 5 years behind American systems. The absence of frequency modulation, the shortage of transceivers, and the lack of proper electrical shielding created vulnerabilities that no amount of armor could compensate for. The Soviets reached much the same conclusion. Granted access to captured German sets, they studied them carefully but ultimately chose to model their post-war designs on American systems rather than German ones. To them, the superiority of FM-based communication was undeniable. The numbers highlighted the gap with brutal clarity. The US produced more than 50,000 units of the SCR 508/528/538 family, enough to equip every one of the 49,324 Sherman tanks built during the war. The deployment rate was essentially 100%. Each set offered 25 watts of transmission power, crystal-controlled frequency stability with a margin of only 0.01%, and an effective range of 7 miles on the move, up to 15 miles when stationary. Germany, by comparison, produced only about 6,000 Fu-G5 transceivers during the same period. With around 12,000 medium and heavy tanks built, that meant a deployment rate of barely 20%. Their sets managed just 10 watts of output, suffered from frequency drift of up to 1%, and often struggled to reach even half a mile in combat conditions. The result was predictable. While American fire missions could be requested and delivered within 3 to 5 minutes, German artillery support often took 15 to 30 minutes, if it arrived at all. The lesson was stark and enduring. The radio advantage of the Sherman established a principle that continues to define armored warfare: reliable, universal communication outweighs raw platform superiority. After 1945, every major military power integrated this lesson into doctrine and design. In West Germany, the newly formed Bundeswehr made sure that every Leopard tank carried comprehensive radio suites. Training manuals openly acknowledged the wartime lesson. The defeat of superior German tanks by inferior American vehicles with superior radios teaches that information dominance outweighs platform superiority. Modern conflicts have only reinforced the point. In 1991, during the Gulf War, coalition forces with unmatched communication networks crushed Iraqi units equipped with technically capable but poorly connected Soviet-designed tanks. Again in 2003, the US demonstrated that network-centric warfare, units fighting as part of a seamless, shared information system, consistently defeats platform-centric warfare, where individual vehicles may be strong but remain isolated. The Sherman story was not just about a tank. It was about a revolution in warfare, waged in the invisible spectrum of radio waves. The radio superiority of the Sherman tank did more than win battles. It fundamentally changed the nature of modern warfare. What mattered most was not armor thickness or gun caliber, but the invisible ability to coordinate, to share information instantly, and to fight as one collective force rather than as isolated machines. By 1945, German crews were learning this truth the hard way. Despite the formidable power of weapons like the 88mm gun, their tanks often fought blind, unable to communicate beyond a short range or across units. American tankers, meanwhile, discovered a new psychological reality. They were never alone. Even when physically separated, their radios tied them into a larger whole, providing both practical coordination and a sense of constant support. Historians later noted that Germany's failure to recognize and respond to this communications gap ranked among its greatest intelligence oversights of the war. Time and again, battlefield encounters demonstrated that US forces were operating with coordination the Germans could not match. Yet German leaders continued producing superbly engineered tanks that fought as solitary giants, while the Americans built good enough tanks that fought as parts of a synchronized system. In the final analysis, the electromagnetic spectrum proved more decisive than steel. The SCR 508 transformed the M4 Sherman from a competent medium tank into something greater, a node in history's first armored battlefield network. Every one of the 49,324 Shermans built during the war carried not just a gun and armor, but 181 pounds of radio equipment that connected it to every other Sherman on the field. That connection created a kind of collective intelligence no individual German tank, no matter how advanced, could hope to equal. Field Marshal Wilhelm Keitel is often quoted at Germany's surrender as saying, "We knew how to build better tanks, but you knew how to make them work together." Whether the words are entirely authentic or apocryphal hardly matters, they capture the essential truth. The revolution that military historians now call network-centric warfare did not begin in the digital age. It began in 1942 when the first Sherman equipped with an SCR-508 rolled into combat. From that point forward, the rule was clear. The network defeats the platform, and the connected defeat the isolated. Modern armies continue to live by that principle. Today's main battle tanks carry advanced digital communication suites, but the lineage traces directly back to the radios that linked the Shermans of World War II. The legacy of the SCR-508 is not just historical. It is the foundation of how warfare is still fought. In the end, the true weapon of the Sherman was not its 75mm gun. It was its voice, carried across miles of battlefield by the invisible waves of a radio.